Good morning. My name is Huỳnh Nguyễn, and today I would like to present the research about the particulate matter monitoring and forecast with integrated local sensor network to the air quality monitoring station. The presentation of my research, including 7 sections, we will go through the section. Um, is evolution is well known as a silent killer, and in Australia, even the number of day exiting the national standard is very limited. For example, um, in 2019, we have a big bushfire as a black summer, but the number of day having the air pollution in Sydney is about 30 days per year. So people have a question that are we really safe with the low level evolution? A recent research published by the Harvard University, they have a finding that even the low level of evolution also very harmful to the people suffering the heart and lung diseases, especially the elderly people. And the WHO also reported that nearly 7.3 billion, that means over 90% of population, have suffered from unsafe level of evolution. Australian government are dedicated to have precise monitoring and prediction. So they use a different type of model. For example, CCAM-CTM, currently used in Australia. Um, they can make a large region prediction, but this model have heavily reliant on the weather modeling, emission inventory, physical and chemical reaction, and other assumptions. So that is quite limited in the accuracy recently, and the government have an urgent requirement for the final scale monitoring and prediction, and especially to enhance the accurate and reliable monitoring and forecast so that they apply the database method, or we know as artificial intelligence approaches for this domain. In the New South Wales state, there are over 15 air quality monitoring stations over the whole state, but in the densely population area in Sydney city, we have around 20 air quality stations. So that the people also use the hundreds of local sensor network. For example, you can see on the map the location of the purple air sensor is a localized information in order to enhance the monitoring system. But in order to fuse the data of the local sensor and the air quality station is big problems. How can we make it more insightful? So in machine learning, people have different methods applied probably in the data-driven methods. For example, in k-mean clustering method, using for divide the data into k cluster, and density-based spatial clustering application with noise or dbScan apply for the high density data. And finally, the hierarchical data clustering method can be applied efficiently in the data-driven approaches. But in air quality problems, we have different complicated concerns. So that recently, in order to cluster general network, there is a very fancy method we call the community detection. So this method not only apply for the data itself, but also can apply for different kind of networks. For example, biological network, social network, and computing networks. So we see that it's very easy to apply not only for other network but also in our monitoring network. So we propose we take a further consideration on the method to solve the community detection. The given Neumann algorithm is one of the most popular one to solve the problems. So for example, you can see over here it has 12 sensor, and when we apply this method, it calculate the connection relationship. We call the centrality between the centrality of an edge. So it can calculate on the connection score, and then for each iteration it will disconnect the weakest one. So for example, over here you can see that after two iteration, two weakest connection can divide it into three, divided the big community into three subclusters. So this show the capacity to account not only the connection, the relationship between the node inside the subcluster, but also formulate the connection, the weak connection between two cluster. So that's the reason why we propose our correlation based given Neumann algorithms. We construct the CGN method as the data collected from the sensor and nearby air quality station has the variance of epsilon correlation. As you can see, there are some period, for example, over here has a very strong correlation, but the other periods has less uh, weaker correlation because of the effect of volatile environments, for example, windy condition, or maybe the rainy season. So in our proposed algorithm, these algorithms will depend on two components: the inverse distance between the sensor and between two sensor, or maybe the sensor to the air quality station, and also the correlation of the data collected from two devices. So our preliminary results will be presented with the data collected from the 14 air quality monitoring stations in suburbs of Sydney and 47 purple air sensor. And we assign 14 air quality station as 14 cluster for easier to compare with the other uh, benchmark models. So the first, you can see four diagram over here show four reasons for benchmark models. Um, the For first three main method, our proposed model, k-mean clustering and agglomerative clustering, showing similar patterns in the northwest Sydney. Because of you can see over here, the number of sensor is quite sparse and limited comparison with the other regions. So the distance is the distance dominant this in this cluster. And for DB scan clustering, the outlier is show as black dots because we can see that the DB scan has cluster the data based on the density. So this sparse location uh, is not considered as a cluster and is considered as an outlier. And the distinguished patterns showing in our proposed CGN method is on the southeast Sydney, and you can see that it cluster the big area, uh, and it show the reflection correlation and dispersion of aerosol of season that align with the previous published finding from the government. In comparison with other methods, they cannot detect this correlation and dispersion of air pollution. And in order to quantify the result, we use the CHOT score, and it shows that our proposed CGN method has the highest performance in comparison with the benchmark models. So in conclusion, our proposed CGN can apply effectively to reflect the dispersion of air particles, and we can use that to cluster the local wireless sensor network to the nearby air quality monitoring station, and the data are applied in the real world scenario by our proposed model. But this proposed method uh, has a kind of exhaustive calculation for all of the centrality score. So that will be our next step for reducing the cost of calculation. Thank you for your listening. Um, this is my presentation.